In this lesson, we'll review a math problem from the grid-in section. We're on page 468, question 16 out of 18, and this is a difficult problem. It's a level 4. A positive integer is trifactorable if it is the product of 3 consecutive integers. How many positive integers less than 1,000 are trifactorable? If you've watched these lessons, you might recall we have what's called a symbol problem, where we have some strange or foreign symbol. It's always defined, and this is similar to it, but the difference is we have a foreign term. There is no such math term as trifactorable. It's in quotes. It could be called anything. It's just a completely fictitious term. It will be in quotes, but just like the symbol problem, there will always be a definition here. So the definition, it's the product of 3 consecutive integers, and we also know the trifactorable is positive, and we want to know how many positive integers less than 1,000 are this term trifactorable. So it's really kind of a difficult problem. It's not really a math question, it's more of a reasoning question. So let's start. It has to be positive, so we know that none of the numbers could be negative or 0. So any negative numbers or 0 are automatically out because the product would not be positive. So let's start with the smallest positive integer, 1. They have to be consecutive, 2 and 3. So you have to kind of work it out, and these are 3 consecutive positive integers, and we know that the trifactorable is the product of them. So we multiply these and get 6, and that is obviously less than 1,000. So this is one term. This is the first. So just kind of keep working. I would just focus on this first term, 1, 2, 3. They have to be consecutive, so we're just going to increase this first term each time by 1, and we get 2, 3, 4, and that's 6 times 4 equals 24. We don't really have to figure these out because these are obviously way less than 1,000. So just keep building and focus on that first term. So 3, 4, 5, that obviously is going to work. We don't have to multiply it out. And then 4, 5, 6, still way less than 1,000. That's another one. And 5, 6, 7. Keep going. Let's do it over here now. So we're going to increase it by 1. 6, 7, 8. Still well less than 1,000. You should recognize that 10 cubed, 10 to the third is 1,000. So we're still way below it. And then we have 7, 8, 9. Still less. Let's keep going, and by the way, let's say you did 7 times 8 times 9, or even 8 times 9 times 10. We don't have to have single digits. These are just consecutive numbers. And here we get 8 times 9 is 72 times 10, and that's 720. So let me just give you one piece of advice. If you ever have a question, not just with this term, but we're given a range less than 1,000. So anytime you see a question where there's an outer bound, in this case 1,000, if you do the problem correctly, the final time will be really close, if not touching 1,000. So you should recognize 720 is still well below it. Let's keep going. We're going to increase this by 1. 9, 10, 11, 90 times 11, 90. See how close that is? That is definitely the final trifactorable term. And so we just count these up, and that's the answer. 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer is 9. Tough question. You just have to pay attention to the terms, do them in a logical order, and just make sure that the final term is really close. If you did this and for whatever reason got a much lower number, it should be an indication you did it incorrectly. It's a grid-in. There's no recourse. But hopefully this helps. All right, the answer here is 9. See you next time. Thanks for watching.